Hi, let me take these off. This is video 2 of quadratic functions. I made one video already about kind of explaining what a quadratic function is, identifying A, B, and C of a quadratic function. In this video, I want to talk about factoring quadratic functions as one way to solve them. And then in a following video, I'll talk about the quadratic equation and how to use that as another means of solving quadratic functions. So just as review, when we are looking at quadratic functions, let me choose an ink color. When we're looking at quadratic functions, they're going to appear on a graph as a curve. So they might look like this, or they might look like this. They're going to appear as a curve, either curving up or curving down. However they appear, they're going to cross the x-axis twice. Almost always, they're going to end up crossing the x-axis twice, so in two different places. So really, when we talk about solving quadratic functions, we're looking for those two places where the curve crosses the x-axis. So today we'll talk about, or in this video, we'll talk about factoring as a way of finding those two x-intercepts. So let's look at an example of a quadratic function that we can factor. We'll look at this one, y equals x squared plus 2x minus 3. So this is a quadratic function. We can factor this, and once we factor this, we will know the two places where this crosses the x-axis. So to start, the first step, we really want to set this quadratic function equal to 0, because that is that's going to tell us when y is 0, that means the curve is crossing the x-axis. So we'll set this equal to 0. 0 equals x squared plus 2x minus 3. Now the next step, it would be to we want to look for two numbers. Let me write this. When we multiply them, they should give us A times C, and when we add them, they should give us B. So there's that A, B, C. Again, remember A is the coefficient in front of x squared, B is the coefficient in front of x, C is the term that doesn't have a variable. So we're looking for two numbers that multiply to 1 times negative 3. So we're looking for two numbers that multiply to negative 3 and that add to positive 2. So let me write this in for us. We want them to multiply to negative 3 and add to positive 2. So I'm thinking about various numbers, and two numbers that I come up with are positive 3 and negative 1. I know that if I multiply positive 3 and negative 1 together, I get negative 3. I know that if I add them together, I get positive 2. And there are no other combinations of two numbers like that are going to do the same thing. There are no other two numbers that are going to multiply to negative 3 and add to positive 2. So once I have those two numbers, here's what I do. Essentially, I'm going to come back up here to 2x, to that middle term, and I'm going to split that in half, and that's going to become 3x minus 1x. So I'm going to split 2x. Let me erase all of this stuff in the middle. Hopefully you had a chance to write it down. I'm going to split 2x into positive 3x and negative 1x. So this gets split into these two terms. And then I'm going to take the x squared right here, and I'm going to take the negative 3 right here, And I'm just going to drop those down without changing them at all. This stays x squared plus 3x. This stays minus 3. So this is my new equation, my new expression. It has 4 terms now instead of 3. So let me write this a little bit higher so that it's starting to run into my face. Let me write this a little bit higher. I'll say x squared plus 3x minus 1x minus 3. So the first step in factoring is to split that middle term into 2 new terms. Now, if I sort of I'm shifted into reverse right now. If I shift into drive and I move forward and I combine like terms, 3x and negative 1x is going to give me positive 2x. So if I shift into drive, I should go back right to where I started. But right now I'm kind of driving in reverse. So continuing, I have 4 terms now, and I'm going to group these terms into 2 sets of 2, into 2 pairs. So I have x squared and 3x on the left here. I have negative 1x and negative 3 on the right. And for each of these pairs of terms, I'm going to find a common factor, something that multiplies into both of those. So on the left, x squared and 3x, their common factor is x. If I factor that out, x squared divided by x is x. 3x divided by x is 3. So again, I'm still shifted into reverse. Now I'm sort of undistributing. I'm factoring out a common factor, and I should end up with a distribution looking problem like this. So then if I shift back into drive and I multiply this together, x times x plus 3, I'm going to get x squared plus 3x. And I'm going to do the same thing on the right. Negative 1x minus 3. A common factor that those both have is negative 1. So if I factor out negative 1, I'm going to end up with x plus 3. Now, at this point, you should notice something. Look at my 2 binomials inside of the parentheses, and notice that they are the same. Those 2 binomials are the same, x plus 3, x plus 3. That's a good sign. If I'm factoring a quadratic function and I get to this point and my 2 binomials match, I'm doing something right. If I get to this point and my 2 binomials don't match, I'm doing something wrong. And I need to kind of take a couple steps back and start over and make sure that I'm heading in the right direction. So the last part here, I'm going to bring this 0 equals back in that we have up there at the top. It hasn't gone away. I haven't forgotten about it. 0 equals, I'm going to write one of those binomials, x plus 3. And then I'm going to take these 2 terms that are being distributed, x and negative 1, and I'm going to create a new binomial using those 2 terms, x minus 1. So this whole process, it's been kind of like driving in reverse. I started with a trinomial, and essentially the whole factoring process is getting back to 2 binomials. And if you've ever multiplied 2 binomials together, you multiply them, you get 4 terms, you can usually combine the 2 middle terms, and then you end up with a trinomial. We did that whole process in reverse, and we end with 2 binomials. What this is saying is that 0 equals x plus 3 times x minus 1. It's the same equation, it's the same function, this is saying the same thing, it's just written differently. And once I get to this point, and I know this is kind of a complicated process, but once I get to this point, I can solve. Essentially, I'm going to take both of these binomials and I'm going to set them equal to 0 separately. 0 equals x plus 3. 0 equals x minus 1. And I want to do that because I'm taking these two binomials and I'm multiplying them together. And this is telling me the answer is 0. If I multiply together these two binomials, it's going to equal 0. The only way that that happens is if one of those binomials actually equals 0. So I'll take both of those binomials and I'll just set them each individually equal to 0. And then I'll solve for x. So I end up with x is -3 and x is +1. Here, 0 equals x plus 3. That's only going to happen if x is -3. 0 equals x minus 1. That's only going to happen if x is +1. So my two solutions here I'm going to end up with are x equals, and let me make some space at the top to write this. My two solutions are going to be x equals -3 and +1. These are my two possible solutions. And I told you expect two solutions. When we get to this point, expect there to be two solutions to this problem. And here we have it. We have -3 and +1. Those are my two solutions. So what that means for graphing, and you may not be asked to do this on the GED test, but that means that I know that the line is going to cross at -3. Let me the line's going to cross at -3 and at +1. So my line is going to cross in these two places. And I happen to know that it's going to kind of curve like this. So this is, if I was graphing my curve, it's going to end up looking something like that. You might be asked to just find these two solutions for x. And factoring is one way to do that. I know that's a complicated process. There's a lot of steps involved. If you didn't catch them all, you can go back, you can rewatch this video. But that is how to factor a quadratic function in order to find the two solutions. I'm going to make one more video, and in that video we'll talk about the quadratic equation, which on the surface looks way more complicated, but I think once we start working with it, you'll realize is way more simple and straightforward than this process. Thanks for watching.